All right, guys, I'm coming to you live from the bathroom. Now, I told you about the Coriolis effect, and your assignment was to flush a toilet, and you guys thought I was crazy. Well, the reason we're doing this is we're trying to figure out if water spins the opposite direction in the southern hemisphere as it does in the northern hemisphere. So I had you flush a toilet for your homework, but didn't tell you why. So if you've ever seen the Simpsons episode on water swirling the opposite direction, they're also, I don't know if it's Mr. Beast, some popular YouTuber, but if you did this enough times, your data will show this one doesn't really spin either direction. It goes straight down. Now, it's not what I call a soul-sucking toilet. A soul-sucking toilet is one of those toilets that you flush and it just goes, and it's gone, right? You ever had one of those where like the pressure, it feels like it's gonna suck you into Minionville? We are going to look at our data and see how many toilets swirled to the right, swirled to the left, and how many you couldn't really tell. Now, we also talked about variables. Variables are things that cause your results to be off or skewed. Some variables could be you don't know right from left. So when you flush the toilet, does your head go to the right or does it go to the left? I also used to use clockwise and counterclockwise, but you guys don't know how to read an analog clock anymore because the school system has failed you and we're all lazy now. But we will go over our results and I'll get back to you. Okay, with the Coriolis effect, that is the name of this. It wasn't just a random thing that I did to have you flush the toilet. Usually there's a method to my madness. With the Coriolis effect, it is showing how water will swirl the opposite way in the northern hemisphere and the southern hemisphere. Now with a toilet, there's actually too many variables. The Coriolis effect happens very slowly. It is the rotation of the earth. It affects wind patterns, weather, water, but it has to be on a large scale. So a toilet is not large enough to show the Coriolis effect. We spin too slowly. Actually, at the equator, you're spinning faster than you are on the North Pole. So if I was sitting on the North Pole and I threw a ball to somebody, it would, towards the equator, the ball would appear to land to the left, okay? Like it was curving or swirling. If I'm on the South Pole, okay, you kind of feel like you're upside down. You're not upside down, but you're throwing the ball and it would look like it lands to the right, all right? Now, if you're on a planet like, what's a planet that spins faster? Maybe Jupiter? I don't know. It happens a lot quicker. So maybe on a toilet there, you would be able to see it. It would be enough volume of water. We're gonna go over some of this so you understand it a little better. I will show you this on a globe to see if you can understand it. Hold tight. All right, I'm gonna use this globe and see if you can understand what I'm saying. So the Earth is always spinning like this. We have the equator here, all right? North Pole, South Pole. Now, if you can imagine, we're standing on a giant ball spinning around and around, rotating around a giant ball of fire, okay, which is crazy, but we're actually standing on this land here on a ball spinning really fast and not floating away. But if we were standing here, let's just say we're on the North Pole and we're looking down, the Earth always spins this same direction. What way does the Earth appear to spin? It spins to the left. Now, if I were to be able to get underneath it, okay, the Earth is still spinning this way, but let's go to the South Pole. I've not changed anything. If we're standing on the South Pole looking up, which way is it appearing to spin? Is it still spinning to the left or is it spinning to the right now? All right, so if you had a large enough volume of water, would the Coriolis effect show? Just like weather, air patterns, and water, it would if you had a large enough volume of water. So you can tell down here, spinning to the right. Up here appears to be spinning to the left. Mind blown, right? Woo, 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 woo. All right, so you guys are wondering why in the world did we have to flush the toilet and what did that have to do with anything? Well, we've learned that it had to do with the Coriolis effect, but the real thing I wanted to show you was in science, I believe science should always be questioned. The phrase, because science, to me, really shouldn't be used, because if we believed in just science because somebody said so and just took it for gospel, we would still believe the earth was flat. That first guy that said, hey, the earth's not flat, it's round, you guys are goofballs, he was laughed out of the room until he brought facts and proved that it was right. So I'm trying to show you that we have to use the scientific method. You have to have facts. You have to be able to prove things. You have to test things. And that's what we are doing with this Coriolis effect, flushing the toilet. There's been lots of studies done on it. There's quite a bit of differing of opinions by people, scientists even, on the effect of this. But basically, I was just trying to show you that you can test things to be able to prove things. So that is it, and that's the end of the lesson. See ya!